seen the first 3-ray diagram. Let's move further with the next 4th ray diagram. It says object at F. So first you make the base diagram. After making the base diagram, you place the object and you place the object at F. After this, students, you all know that you have to make use of any 2 rules to get the image, right? So you use the first rule. If the incident ray is parallel to the principal axis, then the reflected ray will pass through the focus, right? So the first rule is done. Now we use the third rule, right? If the incident ray passes through the focus. Let's see this. Now if I use the third ray, that is if the incident ray passes through the focus, then students, let's see what is the problem. Here you can see that the incident ray is not meeting the mirror. For that I should have one mirror which is very, very big. So what we have to do? Let's see. In order for the rays to be incident on the mirror should be huge. But this is not possible. So we can't use the second ray. So we go for the next one. If you remember the second rule that we have studied, if the incident ray passes through center of curvature, right? We have that rule. So do we have the other rule? Yes, we have 2 rules, right? We have the second rule and we have the 4th rule. We can use any of the rule. Let's use the second rule. It says if the incident ray passes through the center of curvature, right? Then the reflected ray will trace the same path, that it will come back through C. Now students, here you can see the 2 rays appear to be parallel to each other. But actually the rays are not parallel, they will meet somewhere far behind. So we say the rays will meet very, very far, that is at infinity. So I will say that the rays will meet at infinity, that is very far away. Based on that, you have to write the 2 things, that is position and nature. In position, students, where will the rays meet? Very far, that is at infinity. Next comes nature. Nature, first is real. Why real? You all know. As the rays are actually meeting, but where are they meeting? At infinity, very far, right? The next one, if they are meeting, if it is real, then you all know it is inverted. So real images are always inverted. Finally, you will get an image which is very, very big, right? Because the rays will meet very far. So I say the image is highly magnified. Why highly magnified? As the image height is very large as compared to that of the object. So that is the 4th diagram, object at focus. Now students, let's move further with the 5th ray diagram, that is object between P and F. So first thing, you make the base diagram. After you make the base diagram, students, what you have to do is you have to place the object between pole and focus. Now we use the first rule. If the incident ray is parallel to the principal axis, then what happens is the reflected ray passes through the focus. Students, after this, let's go for the second rule. If the incident ray passes through the focus. Now students, if I make this incident ray passes through the focus, then the reflected ray will be parallel to the principal axis. But students, if you see the incident ray, it is going somewhere outside the mirror, right? It is going ahead. So I say that in order for the rays to be incident on the mirror should be very, very huge, right? This is not possible. So you can make use of other 2 rules. That is, we'll go for the second rule, incident ray passing through center of curvature. So now students, we have the other rule with us, right? That is through C. If the incident ray passes through the center of curvature, then the reflected ray traces the same path. So if it is passing through C, it will come back through C. Now students, see the diagram. You can see something. The rays will not meet as the rays are diverging. Here you can see the rays are going away from each other, right? So in order to make the rays meet, what you have to do? You have to extend the ray behind the mirror. So when we extend it behind the mirror, students, you have to make it dotted line, right? So we say, but the rays appear to meet behind the mirror. They are not actually meeting. We are making them meet behind the mirror. Where they intersect, you make a dotted image and you name it as A dash, B dash. This is a virtual image, student, because the rays appear to meet. They don't actually meet. After you obtain the image, what you write is the position of the image. Where is the image? We say the image is behind the mirror. Now comes nature of the image. Nature, now obviously it is not real, so we say it is a virtual image. Why virtual? As the rays are appearing to meet behind the mirror. Next, whenever it is real, students, you know it is inverted. Whenever it is virtual, it is erect. Why erect? As the image is formed above the principal axis. When the image is formed above, then it is erect. Finally, we say magnified. The image is magnified. Why magnified? Because its height is bigger as compared to that of the object.